magnetone. On July 30, 2020, an Atlas V rocket stood ready at Cape Canaveral, prepared to send Perseverance.
The powerful Atlas V rocket ignited, marking the beginning of a 7-month voyage across 300 million miles of space.
After reaching orbit, the spacecraft separated from its booster stages and set course for Mars.
The destination, Mars, and a cold, dusty world that may hold secrets about life beyond Earth.
The landing site chosen was Jezero Crater, a 28-mile-wide basin that once held a lake over 3.5 billion years ago. Scientists believe this ancient lake and river delta could preserve signs of microbial life from Mars' wetter past.
What was once a thriving aquatic environment is now a dry, desolate landscape. But the rocks remember.
Meet Perseverance, or Percy, a car-sized robotic geologist equipped with the most advanced science. Perseverance is a marvel of engineering, measuring 10 feet long, 9 feet wide, and 7 feet tall, weighing 6 aluminum wheels, each with its own motor, allow Percy to navigate the treacherous Martian terrain.
To safely land this precious cargo, Caucasian female engineers designed the innovative Sky Crane landing system.
First, a heat shield protects the spacecraft during the fiery descent through Mars' thin atmosphere, withstanding temperatures up to 20.
At supersonic speeds, a massive parachute deploys, measuring 70.5 feet in diameter, the largest ever sent to Mars.
The Sky Crane's 8 retro rockets fire, slowing the descent to a gentle hover above the surface.
Like a cosmic crane operator, the descent stage lowers Perseverance on nylon cables for a soft touchdown.
On February 18, 2021, Perseverance's wheels touched Martian soil. A perfect landing after 7 minutes of terror.
Its job complete, the Sky Crane flew away to crash at a safe distance, protecting the rover from debris.
Unlike solar-powered rovers, Perseverance is powered by a nuclear battery, a multi-mission radioisotope.
The RTG converts heat from decaying plutonium-238 into electricity, providing reliable power for at least 14 years.
This nuclear power source ensures Percy can work through dust storms and during the dark Martian winter when solar panels would fail.
Tucked beneath Perseverance's belly during the journey was a small but revolutionary passenger, the Ingenuity helicopter.
The Ingenuity, weighing just 4 pounds, was designed to prove that powered flight is possible in Mars' thin atmosphere. Its 2 sets of blades spin in opposite directions at nearly 2,400 RPM.
This high speed is necessary because Mars' atmosphere is only 1% as dense as Earth's, providing very little lift.
On April 3, 2021, Ingenuity was gently lowered to the Martian surface, ready to make history.
On April 19, 2021, Ingenuity achieved the first powered, controlled flight on another planet, a Wright brothers moment for Mars.
What was planned as 5 test flights became over 50 successful missions, far exceeding all expectations.
Ingenuity evolved from a technology demonstration into an aerial scout, helping plan Perseverance's routes.
Perseverance carries 23 cameras, more than any Mars mission before it, serving as the rover's eyes.
The Mastcam-Z stereoscopic camera system captures stunning 3D panoramas in vivid color.
The SuperCam can zap rocks with a laser from over 20 feet away, analyzing their chemical composition from the vaporized material. Navigation cameras provide 3D vision, allowing Perseverance to autonomously avoid obstacles without waiting for commands from Earth.
This autonav system lets Percy safely travel up to 393 feet per Martian day, making its own real-time driving decisions.
One of Perseverance's most groundbreaking experiments is MOXIE,
the Mars Oxygen In Situ Resource Utilization Experiment.
MOXIE takes in Mars' carbon dioxide-rich atmosphere, which makes up 96% of the air on the red planet.
For the first time in history, we've produced breathable oxygen on another planet, about 10 grams per hour.
This technology could one day produce oxygen for future astronauts to breathe and create rocket fuel for the return journey home.
Perseverance's 7-foot-long robotic arm is equipped with a drill to collect core samples from Martian rocks.
The drill can bore into rocks, extracting cylindrical cores about ½ an inch in diameter and 2.4 inches long.
Each sample is a time capsule, potentially preserving evidence of ancient Martian life from billions of years ago.
After collection, samples are sealed in ultra-clean titanium tubes to prevent contamination. Some tubes have been carefully deposited on the surface, creating a backup cache at Three Forks site. Perseverance carries 43 sample tubes and has already collected dozens of precious specimens. These samples await a future Mars sample return mission, one of the most ambitious endeavors ever planned. A future mission will land on Mars, collect these tubes, and launch them into orbit.
An orbiter will capture the sample container and begin the long journey back to Earth. When these samples reach Earth, they'll be the first rocks returned from another planet, allowing scientists to study them with lab.
The ultimate goal is finding biosignatures, evidence that microbial life once existed on Mars.
Jezero's layered sedimentary rocks are prime hunting grounds, formed when water deposited minerals and sediment. The Sherlock instrument uses ultraviolet laser spectroscopy to detect organic molecules and minerals altered by water.
Pixel uses X-ray fluorescence to map the chemical composition of rocks at a scale finer than a human hair.
These instruments have already identified minerals formed in water, confirming Jezero once held a lake and river system.
For the first time in history, Perseverance carries microphones, allowing us to hear Mars.
These microphones have captured the sound of Martian wind, the rover's wheels crunching on rocks, and Ingenuity's blades whirring.
Sound travels differently on Mars. Higher pitches are absorbed more than on Earth, creating an eerie, muffled soundscape.
We've even heard the crack of Supercam's laser striking rocks, providing acoustic data about rock hardness. The Mars Environmental Dynamics Analyzer, or MEDA, monitors weather conditions like a meteorological station.
MEDA records temperature, pressure, humidity, wind speed and direction, and dust particle sizes.
These sensors have detected hundreds of dust devils, spinning columns of dust similar to small tornadoes.
The RIMFAX radar peers beneath the surface, mapping underground layers of rock, ice, and soil.
This subsurface map reveals the geological history preserved beneath our feet, showing ancient flood deposits and volcanic rock. Even Perseverance's calibration target serves science, carrying samples of spacesuit material to test their durability. Perseverance also carries the names of 10.9 million people etched on silicon chips, humanity's signature on Mars. A special plaque honors healthcare workers worldwide who persevered during the COVID-19 pandemic.
Perseverance joins a family of Mars rovers, building on decades of exploration since Sojourner first rolled on Mars in 1997.
Every track Percy leaves tells a story of exploration, covering miles of terrain never before touched by Earth.
And in quiet moments, Perseverance captures the alien beauty of Mars. Sunsets that glow blue instead of red. Over months of exploration, Perseverance has traversed the crater floor, exploring the ancient river delta's remnants.
Each significant rock receives a name, becoming part of Mars' growing catalog of geological wonders. The delta front has revealed beautifully preserved layers, like pages in a book written by ancient Martian water.
Multiple instruments have detected organic molecules, carbon-based compounds that could be building blocks or remnants of life.
Look at the layers in the canyon wall.
That's it. Definitive proof of the ancient lake bed.
We found it!
Perseverance has witnessed Martian seasons change, watching frost form and dust storms brew. The rover has even captured eclipse-like events as Phobos, Mars' larger moon, passes in front of the sun.
At night, Perseverance has gazed at stars. In the Martian sky, Earth appears as a bright evening star, with our moon visible as a tiny companion dot.
Each rock sample tells a different chapter of Mars' story, from volcanic origins to water-altered sediments.
Now, Perseverance ascends the delta's steeper slopes, reaching rocks deposited when water flowed strongest. The terrain grows more challenging, but Perseverance's advanced autonomy keeps it safe.
The mission has years of exploration ahead, with scientifically rich sites awaiting investigation.
Perseverance is preparing the way for future human explorers, proving technologies they'll need to survive.
MOXIE has demonstrated that future astronauts could produce their own oxygen and rocket propellant from Mars' atmosphere.
With each discovery, our understanding of Mars transforms from a dusty mystery to a complex world with a dynamic past.
Though its wheels show signs of wear from the harsh terrain, Perseverance remains strong and capable.
The nuclear battery continues providing steady power, unaffected by the seasonal dust that would cripple solar panels.
Every command to Perseverance takes up to 20 minutes to arrive, meaning the rover must think for itself.
Orbiting spacecraft, like Mars Reconnaissance Orbiter, serve as communication relays and scout locations from above.
Perseverance joins a legacy of successful Mars missions that have collectively explored less than 1% of the planet's surface.
Evidence suggests ancient Mars was warmer and wetter, with conditions potentially suitable for life. Understanding how Mars lost its water and atmosphere helps us appreciate Earth's fragile climate.
Finding even fossilized microbes on Mars would revolutionize our understanding of life's prevalence in the universe.
Alone on a distant world, Perseverance represents humanity's curiosity and drive to explore.
From landing to flying, from drilling to discovering, this mission has achieved milestone after milestone.
As each Martian day ends, Perseverance prepares for tomorrow's discoveries, tireless in its quest.
The Mars 2020 Perseverance mission continues to write humanity's story across the stars.